Bismillahirrahmanirrahim. Students, today we have to study about clamping load and tightening of bolted joints. Clamping load. When a bolt or screw is used to clamp two parts, the force exerted between the parts is the clamping load. The designer is responsible for specifying the clamping load and for ensuring that the fastener is capable of withstanding the load. The maximum clamping load is taken to be 0.5 times the proof load, where the proof load is the product of the proof stress times the tensile stress area of the bolt or screw. Tightening torque. The clamping load is created in the bolt or the screw by exerting a tightening torque on the nut or on the head of the screw. An approximate relation between the torque and the axial tensile force in the bolt or screw. The clamping force is, as you know, stress is force over area. So force will be stress into area. So and that is the relation which we are using here and also here. So the approximate relationship between the torque and the axial tensile force in the bolt or screw is T is equal to KdP, where T is torque in pound inch, D is nominal outside diameter of the threads in inches, P clamping load, K constant dependent on the lubrication present. So if you have different lubrication, then the value of K will be different. For every commercial conditions, use K is equal to 0.15 if any lubricant at all is present. Even cutting fluid or other residual deposit on the threads will produce condition consistent with K is equal to 0.15. If the threads are well cleaned and dried, then we have to use K is equal to 0.2 is better. Of course, these values are approximate and variation among seemingly identical assemblies should be expected. Testing and statistical analysis of the result are recommended. Now we have to solve first example of this chapter, chapter 19, example 19.1. A set of three bolts is to be used to provide a clamping force of 12,000 pounds between two components of a machine. The load is shared equally among the three bolts. Specify suitable bolts including the grade of the material if each is to be stressed to 75% of its proof stress. Then compute the required tightening torque. So we have to find the tightening torque. For solution, we have to know about what will be the load on each screw. So that will be 4,000 pound. Let's specify a bolt made from SAE grade 5 steel having proof strength of 85,000 psi. Then the allowable stress is, that will be 0.75 of the proof stress. So if this is the proof stress, then we have to multiply it by 0.75 as we have read just before, and the answer is 63,750 psi. The required tensile stress area for the bolt is then area will be actually the force into the stress, and force is 4,000 divided by 63,750. So area will be 0.0625 in square. From table 19.4b we find the 3816 UNC thread has the required tensile stress area. The required tightening torque will be KdP. K is 0.15 as we have read. D is 0.375 inches here, and the force, that is 4,000, and answer will be 225 pound inches. So if we have to know about the table, we can go at table. So for this diameter it is 3816 UNC coarse thread, so we have to use this one. All right, so now set of three bolts 12,000, 1 volt will be 12,000 divided by 3. That's why it is 4,000 pound. These are three volts. That's why 1 volt will have 4,000. So K we have to use 0.15. So this is the way how we can calculate this. So please practice this example at your home. So that is all from my side. Thank you, class.